right, part 3 of solving radical equations. So you might expect these might be a little bit more complicated, but we can do it. So here you've got radicals on both sides. So I'm going to go ahead and square both sides so that I just get x plus 1 equals 2x plus 4. And then I can solve it like I would any regular old linear equation by getting x by itself. So I'm going to subtract x from both sides and then subtract 4 from both sides and end up with x equals -3. So if you plug that back into check, you do need to plug it back into the very original that had radicals on both sides and make sure that you get both sides to be the same value. So if you do that, here we're going to get the square root of -2 on both sides, which those are the same thing, they're equal. So x equals -3 is a solution. If you look at this one, it's got a cube root on the right-hand side. So before I can get x by itself, I need to get it out of that cube root by cubing both sides. Now be a little careful when you cube 2x. Think about taking it times itself 3 times, which gives you 8x to the third. And then I have x to the third and x. I need to get them both on the same side of my equation so that I can do a little bit of factoring out a common factor of 8x. And then, if you haven't factored for them, we could even factor a little further on that x squared minus 1, factor it into x plus 1 and x minus 1. Now that you have it in completely factored form and everything's equal to 0, set your 3 factors equal to 0 and see what values of x you get. You could have done that without factoring the x squared minus 1, 2, and solved it by taking a square root. So you'll end up with 3 potential solutions, 0, 1, and -1. Now you do need to check all 3 of them in your original equation. So if you do like 2 times 0, see if that's equal to the cube root of 8 times 0. Well, 0 is equal to 0, so we're good with x equals 0. If you do positive 1 and -1, I'm going to do -1 first here. I've got -2 equals the cube root of -8. That's -2. And if I do positive 1, I've got 2 equals the cube root of +8, which is also true. So all 3 of those work. Here we have another one where one side is inside a radical and the other is not. So I'm still going to need to square both sides to undo my radical. And if you square x minus 6, remember you're multiplying that entire binomial times itself, just like you're really doing on the right-hand side. But on the right-hand side, that just gives you 2 factors that are the same inside your radical, and you just get 3x. So when you multiply x minus 6 times x minus 6, make sure you multiply it all out and get your middle term of -12x. And then it's a quadratic, so we could get 0 on one side and potentially factor or a quadratic formula. Let's see, I could guess and check it, but I'm gonna find the 2 numbers that multiply to a times c, so to 1 times 36 is 36, and add up to -15, and then I'll factor it by grouping once I split that middle term. Let's see, 36, 12 and 3. I need -3 and -12 to add up to -15 and multiply to +36. So if I rewrite that middle term as a -3x minus 12x, I can then make a couple of groups and factor out a common factor. I'll factor an x out of that first pair of terms and a -12 out of that second pair, which will leave me with x minus 3 as a factor of both of those. So I can factor that out and then have x minus 12 remaining. So if you set each of those factors equal to 0, since my entire equation is equal to 0, I'm going to get x equals 3 and x equals 12. Plug them in and check them. I'm just going to kind of jot it at the top here. So let me do 3 first. 3 minus 6, we need to see if that equals the square root of 3 times 3. Well, that's -3 on the left and +3 on the right, because the principal square root of 9, which we're finding, the square root of 9, is actually just +3, not -3. So that's no. If we do 12, we've got 12 minus 6, see if that's equal to the square root of 36. That is +6, which is equal to the square root of 36. So one of those values worked, 12, the other did not.